I think it's important. We are scientists here. We are used to deal with, for example, the laws of thermodynamics. But if we think about energy service and the energy input to get that services, that is an equation which is not governed by the laws of thermodynamics. We can get much more than what we can see from the laws of thermodynamics. So I will give you some examples from how this can be reached. And one example is from not far from here. Grand Hotel have a project they call Sustainable Hotel. And one of the things which they have done there to increase the energy efficiency is just to change the incandescent lamps in the chandeliers and to other types of modern lighting. And this has reduced the energy use of each of these lamps from 25 watts to 4 watts. So a factor of 5 just by changing the lights. And there is no, the light is not worse just because it comes from a more efficient type of lamp. Also, they have changed the spotlights in the corridors, and they have also changed the lighting of the winter garden, reducing the capacity by 41 kilowatts just for the lighting. And also, in total, they saved 128 megawatt hours just in the winter garden. And not only that, by changing the lighting in the corridors, they also use less air conditioning to cool the building. So this is an additional gain they got just by reducing or changing the lighting of the building. Also, if we look at the refrigeration and the systems they are using there before they had 4 10-kilowatt compressors installed, and they were rejecting the heat from these compressors, the cooling systems, to the ambient air. Then they changed to using a heat pump instead and used this heat from the cooling system for producing sanitary hot water. So after that, they got the same cooling capacity, of course, but they could use all the heat from the hot side of the systems, which is then 3 times as much as the cooling capacity for heating purposes. Of course, if we build new buildings, we can go much further than this. We can construct buildings today which do not need any energy from the outside to maintain a good indoor climate. It is just a matter of what we aim at. I have also a number of examples here from industry, from one of my colleagues, or one of my students, I should say, who is now working out in the industry on energy, making the energy use more efficient. So this is from in a case where they exchanged active cooling by compressor refrigeration machinery to free cooling, saving of 180 megawatt hours per year just in this industry. Payback time was less than or about 2 years. Another example is where they reused the ventilation air from the buildings with a saving of 1,300 megawatt hours per year. Payback time for this was about 1 year also. A third example is from the pulp and paper industry, where they, by introducing frequency control of the motors, could get an energy savings of 355 megawatt hours per year. And also in this time, the payback time was about 1 year. And the fourth and last example from the industry, also concerning frequency controls of motors for fans, energy saving 430 megawatt hours per year, a payback time close to 1 year. So there is a lot to do in the industry and also in other branches for reducing energy use. Of course, new technology also has to be developed, and I think there is a lot of areas where we need research to reach these energy efficiency goals which we should have. And just to give you one example as an example of this, this is a case where they have developed a new type of system for reducing the friction or underneath the boat hull by pumping pumping air in under the boat, so that the boat runs on a cushion of air. And they also changed the shape of the hull. And this is just examples of changes which can be done, which do not influence the use of the technology or the climate we have in our houses, etc. There is no loss combined with this type of change of technology. So with that, I will close my short presentation here. The key of my presentation is then that with the energy option we should get more from less. Thank you.